So phi sigma square 1 plus phi square plus phi is to 4 and so on, right? This is what? So this is phi sigma square 1 plus phi square square like that it will be. This will become a geometric series. So this will become phi sigma square 1 minus phi square. Because there's a geometric series in 1 plus phi square, 1 plus phi square is phi square, right? There's a geometric series in phi square. So what we get is phi sigma square upon 1 minus phi square. That is covariance between yt and yt minus 1. Does this depend upon time? No. Because phi is a constant, sigma square is a constant, 1 minus phi is a constant. But if phi is equal to 1, this is not defined at all. Yeah? If phi is equal to 1, this is not defined at all. So yt minus 1 का covariance कुछ है ही नहीं. Covariance कुछ है नहीं इसलिए correlation भी कुछ नहीं है. See the point? Yeah? So we have what is called the stationary AR1 process. Yt is equal to alpha plus phi yt minus 1 plus et. When the absolute phi is less than the stationary AR1 process. Whereas phi is equal to 1, we have the random walk with the drift. Random walk with the drift is a non-stationary process. Now comes the critical interesting point that I want to talk about. Right? See, what is yt? Think of in general. Think of in general a process which is think of in general process like this. Then you can write this process as assume that phi is less than 1. Then you can write this process as yt is equal to plus like that I can go on, right? Right. Well, what is EP? What is EP? EP is a shock in time period T. What is EP minus 1?
Previous
Time
period.
period T minus 1. So we want to find out what is the impact on the process at time period yt of a shock in time period T. So we have to find the impact on yt of a shock in time in the same time period. What do I have to do? For that I have to calculate derivative of yt with respect to et. How much does et affect yt? Right? So if I do delta yt by delta et, what will I get? Derivative of yt with respect to et, what will I get? 1. 1. Now if I want to find out the impact of et minus 1 on yt. So system को shock आज हुआ है. I want to find its impact on the biological system tomorrow. So what will I have to do? Differentiate yt with respect to what?
T minus 1.
T minus 1. So what will I get?
5.
Pi, right? Right? Then Pt minus 1, right? 2 period back के लिए क्या करूँ?
5 square.
Pi square, right? Now you see phi is a number less than 1. So phi is less than 1, pi square is less than 5. So what it says is the shocks which have been received in the past, their impact for the current value of the series keeps on declining in time. So जितना पुराना आपको शॉक लगा है, उतना उसका आज का impact कम है. The smaller the phi, the better, the faster that impact goes, right? This is called the impulse response function.
Impulse response.
Right? It tells you how the shock received in time period et affects the future values of y or the current value of y पकड़ेंगे तो current shock का क्या impact है, 1 period past shock का क्या impact है, 2 period past shock का क्या impact है, 3 period past shock का क्या impact है, right? Okay, then you get a process which is we call if you find this, if you plot say pi square, pi cube, pi raised to 4, etc., etc., you get some series, right? If phi is positive, the values will keep on declining like this. If phi is negative, then positive negative change होगा ना power, right? So you get a picture like this. So this is called the impulse response.
So the shock is in the past period. Just the first past period will be imposed on the current period.
Yeah, the current period का तो एक impact. Last period का phi. 2 period back का phi square. 3 period back का phi cube. So j period back का phi raised to j. So impact will कम होता है, right? Now what if phi is equal to 1? एक तो alpha minus phi is not defined होता है, right? And secondly, what is delta yt by delta et1? Delta yt by delta et minus 1, delta yt by delta et minus 2 is 1, delta yt by delta et minus 3 is 1. So the impact of the shock never wears out.
Constant.
The impact of the shock never wears out. It always
It follows stationary
remains in the process for all time to come. So if it is a random walk, if it is a sudden disturbance in the random walk, the impact will be carried in the process for all its time period. Whereas for a stationary process, the impact will be there and then it will wear out slowly. Right? So if you have a stationary process, okay, the difference is like this. If this is the mean value of a stationary process, right? And the shock, then the process will have an impact and the process will slowly, the impact will slowly wear out. Right? If this is a process, this is the mean value of yt. The shock to yt. Yt will rise first for some time and then yt will slowly decline as the impact of the shock wears out. For a stationary process. For a non-stationary process, क्या होगा? If this is the value, it will jump permanently. If it is a positive shock, the level of the process will change permanently because the impact of the shock will remain in the series for all time. It's just a random shock. Et is a random variable with a certain probability distribution. No. Whatever, suppose Et has a certain value, E star. So it will change the value of yt by that quantity and that impact will never go away. Say, for example, GDP is a random walk and suppose there is a drought. Then the impact of the drought is not going to wear off over the long term. Never going to return to the pre-drought times. It means that the impact of the drought will affect the economy for permanently. Yeah, if there is an oil price shock, the oil price shock will be retained in the series for all time to come. All asset prices are random walks. So if you're looking at a stock, if you're looking at say a share price, and suppose there is some random shock which happens to the company's earnings, for example, then the impact of that event is not going to wear out. It's going to be there in the series for all time to come.
So it will not even reduce.
It will not reduce.
Even if it reduces.
Millions of years. Yes, because always relative will be 1. No? That's the good thing about random walk. So random walk process is called a process of infinite memory. Whereas a stationary process is called a process of finite memory. आप भूल जाते हैं ना? कुछ shock हुआ, over time you forget, right? Okay? But a random walk is a process which never forgets. कुछ हुआ तो lifetime उसको remember करता रहता है कि हुआ था, right? Okay? So this is a process of infinite memory. Whereas a stationary time series is a process with a finite memory. Its effect varies. This is very, very important. Because for a random, what it means is, if there is a stationary time series, if the disturbance it will come back to its mean after some time. Non-stationary process होगा ना, it will keep on moving away from its mean. तो इसका mean अगर होए भी तब it will not necessarily come back to its mean. Right? It will keep on meandering further and further away from its mean depending on the shocks. So therefore, such kind of time series are also sometimes called processes with stochastic trends. Because the trends in the series itself are variable. They depend upon the random walks and all that. They depend upon the random shocks. So the processes with stochastic trends. Right? Okay, so tomorrow I think now what Sanjay will teach you and Mank will teach you is how to test. There is an ADF test to be done and that is the end of our syllabus.
So paper